Hey, thanks for joining us. So we're gonna get started and welcome to CS and AI webinar from the Trails of Lights series. Thank you, Shadi and Kimia Jun, for putting this together. I'm Hiva, and we have three of our amazing panelists. And today we're gonna talk about everything computer science and AI and it's kind of what our his stories have been and also like what it's gonna look like. But without further ado, what about we get started with introductions? Hooman, do you want to get us started?
Sure. Thanks, Hiva. So hi everyone. My name is Hooman. Um, I go by Adam sometimes on LinkedIn and people who can pronounce me, but for this session, I think we can stick with Hooman. Yeah, I did my bachelor's at UC Davis Computer Science. I was a pre-med student initially, and then master's at Georgia Tech in the AI concentration. And then I joined the industry in 2018, so I guess about 7 to 8 years of experience now. Places like Magic Leap, Coinbase, TikTok, AWS, and most recently Meta. I've also advised a health tech startup as an interim CTO, and I had my own bootstrap one. Really excited to share my experiences with the audience here.
Thank you. Great to have you. Arya, do you want to go next?
Yeah, sure. Hi, I'm Arya. Um, yeah, I guess I started off with CS at college. I didn't know how to code when I got to Berkeley. I came in as like a physics major. I thought I wanted to do like EE. And then I took this like really nice class, like CS 10, and the teacher was really nice. And as you do at Berkeley, you meet a bunch of like nerdy people. And then I got like nerd sniped into like ML stuff, and I thought self-driving cars was cool. Also at Berkeley, the CS major allows you to take all the EE classes. So I was like, okay, I'll switch into CS, and then I'll become an EE after that. Um, and then I kind of got nerd sniped by the ML stuff, and then so I kind of more and more just kind of started getting into the math needed for ML as opposed to the physics and math needed for EE. Um, and then yeah, so I kind of like slowly got into that. I still really liked building hardware and stuff. I did like high school robotics. So I was like chief engineer, like senior year, I was like chief engineer of like the electric race car team. So we build this big electric race car. It was like a team of like 50, 60 students. Maybe like 30 kids actually did the work though. And then we would go race them against other teams in Michigan, and that was really fun. Kind of taught me more about hardware and stuff like that. And then I was also doing research in this professor called Sahai's lab. And then so for that research, we were doing like brain state classification. So we would take EEG signals and try to read your brain. So we would, and then anonymize your signals. So we could take your signals, detect if you're like a woman or a man, your age, if you have like a Parkinson's diagnosis. And the goal was to use these models called diffusion models to edit your data to make it seem like, oh, this is a 60-year-old woman with Parkinson's as opposed to like a 20-year-old woman with Parkinson's, something like that. And then, yeah, I guess all that to say is like after that, I worked at Amazon for like a year and I just really hated it. Or I didn't hate it. I really liked my team. It was really, really like great people, but I wasn't learning as fast as I like wanted to. Um, and then after that, it was like after the year, I'd like decided to do my own startup. So for the like last 2 years, I've been working on this startup like Camfer. And so the goal of this startup was to essentially like do cursor but for CAD is what we've been working on. Like as of right now, we're like kind of winding it down though. So that's like a hot take. So I have all the experience of like starting it, bringing it down and looking for other stuff. But yeah, that's me right now. So happy to answer any questions. But yeah.
That's awesome. Yeah, we're gonna definitely get deeper into those things that you mentioned, but thanks for giving that introduction. It sounds really cool. Amirhesam, do you want to go next?
Yeah, sure. So my background actually comes from electrical engineering. I did my bachelor in Sharif in Iran. So back then it was, I didn't know anything about machine learning. So basically I was working on RFIC, chip design, very like traditional electronics. And then I applied for PhD and I get my first PhD at the University of Southern California. But I was kind of lucky. It was like a fellowship, so I had a whole year to just explore many, many different like topics. Back then, there was like three main topics that were very hard. One of them was quantum, one of them was machine learning, and one of them was cryptography, of course. And I had no idea like any of this. I remember it was like this talk, and even with the standards of 2018, it was like a pretty old thing, but I was very impressed that they have like a mathematical algorithm that can tell you whether the image is dog versus cat. I said, okay, this is like the aha moments. They're just taking 0 to 1. It's like a very different. We've never had something like this. Or maybe there were something, but I wasn't aware of. So I was very impressed and said, okay, this is something I need like to work more on it. But my background was not in machine learning at all. I didn't even know linear algebra. So I started like taking math courses. I thought like I wish I had like a bachelor in mathematics instead of electrical engineering. But so I said, okay, it's not too late. I get like a master in computer science while I was doing PhD at USC. And then I decided, okay, I spent like 2 years already in my PhD and I just learned the stuff and did a lot of courses. This is like not good enough for a PhD. So I applied for a new PhD, this time for computer science. And back then in around like 2020, 2021, it was like super exciting to come up with a theory for basically machine learning. So everyone was just trying to come up with like a principled way to understand this algorithm. And I said, this is the way we have to really understand these algorithms. So my PhD was at UCSD. It was like this theory professor. I was very lucky to get in. He was like a big name in theory. And then after the first 2 years, my PhD, then ChatGPT came out and it changed everything. And now we have like this very, very complex like machine that can talk, that can show some sign of like human intelligence. And the theory was about two-layer MLP. So that was like another like aha moments that we are kind of screwed. And then I kind of decided like to change like direction a little bit. So now apparently this system cannot really be understood through the mathematical lens, but how about like from the physics point of view? So we have like this complex machine, they do like do amazing things, and I cannot prove anything mathematically about it. But what if I study it and come up with like the rules that can help me to identify the universal rules that actually govern the whole machine learning models kind of realm? And if I can find like those rules, now I can actually do something with it, make them better or make them worse. I don't know. But that's actually what my trajectory was. And I'm still like doing PhD, so I'm the fifth year of like PhD.
That's awesome. Yeah, our Tori and PhD person over here. Yeah, excited to get to know in those like get deeper there as well. But yeah, I can give some introduction about myself as well. I'm Hiva. I'm doing my master's at Stanford right now in computer science. I like Arya. I never thought I was gonna do computer science. I was gonna do like math and just do like fun stuff with math. I just like math. But it was like I game design course in high school and like I got into the CS category of like getting into like understanding category like CS and like building something with hand. Like that was just really cool. And then during my undergrad, I was kind of like all over the place. I went into Berkeley like thinking that I was gonna do like software engineering and go to like this big tech and like just do the traditional like software engineering route. But then like just like Amirhesam said, like ChatGPT era and like these models came out and you can't help but to just like get your hands dirty with these models and like do research and development with them. So I also like took the route of like doing research in the LLM space, so large language models, basically making them more efficient during inference. But yeah, so and now I'm doing my master's and continuing that, still trying to figure out I'm going to be doing. But I just want to take a moment here and just tell everyone that like all of us come from different backgrounds, and one thing that we want to talk about is like computer science is kind of like shown as this field that's hard to get into and like everyone kind of knows what they're doing in the domain. but that's not the case. A lot of people are just trying to like figuring it out as we go, and there's a lot of diverse backgrounds in that field. So that's what we're gonna do, and just to let everyone know, we're gonna do like 50 minutes of talking, and then hopefully like 10 minutes at the end for Q&A, so that we can answer some questions from the people that joined as well. But I want to kind of like go back into kind of like what you guys shared a little bit about like what was the reason why you get into like computer science and AI. Like what actually sparked that, and like what did you like, did you have any coding experience before going to classes? Like did you have a specific class that like sparked? I know some of you have already mentioned, but kind of like was there any push from your parents to do this? So I want to know a little bit about like what was the process of getting into the field like? And maybe we can start with Hooman, maybe because you didn't share a lot.
Sure. Yeah, great question. Actually, I come from a family of doctors, so my parents were pushing me to go to medical school, and it worked on my older sibling, my sister. She's an oncologist now, but it didn't work on me. So I was again, psychology major, joined UC Davis, planning to go to med school. Keep in mind that I moved to the States when I was roughly 16, 17, so junior year of high school, right sort of in the middle. And as a lot of you might know, it's the year that you apply for college. So a lot of your path gets sort of planned around that time. So for me, my objective was to just kind of get to, a research university that has good credentials and also something that is, manageable in terms of cost, and I can get the scholarship and whatnot. And before going to college, we moved to the Bay Area. So I took a class at Stanford while I was playing at a tennis camp during high school. So I took CS 106A actually. And it's the introduction to programming with Java at Stanford. It's a very popular course. It's completely open source on YouTube and iTunes and their website right now. And I took it with an instructor that was actually working at the industry. His name was Nate, and he was such a cool guy, like very enthusiastic. He taught us about the concepts, and actually, I was kind of fearful when I was taking it. All these kids already knew how to like make their terminal look colorful, and also like knew how to code, and it was a large class. So I was able to like find few people like who were non-CS majors and kind of felt like they were helpful. So we kind of formed a group and kind of learned as I went through that program. And it sparked my interest in like coding in general, like how to write a program, how to make, kind of a digital robot move. We made the game Hangman, which was pretty interesting as the first like game that I ever created using Java. And then when I went to college, I was taking like biology, chemistry, life sciences, mathematics. And then I didn't tell my parents, but I started taking CS classes on the side as an extra course. And I was kind of like really getting more into it, getting more in depth. I started with C at UC Davis, and it was pretty difficult course actually. And by end of freshman year, I kind of was acing my CS courses, not doing really well in the biology courses. So I made the choice after talking to advisors, mentors, and I also had a second cousin who worked at Google at a time. So she gave me a tour of the campus, and I totally fell in love with like the free food and all the entertainment they have in big tech companies in Silicon Valley. I was like, oh, I can see myself working here rather than seeing patients in the hospital, with blood and emergency room and whatnot. So yeah, that's I took the route. My parents visited me over the summer. I told them that I'm officially a CS major, and I'm not doing medical school anymore. And yeah, that was the initial spark for me.
Awesome. We love that. We love that doctor meant to be the turned into an engineer. We like that. Um, yeah, so maybe we can ask maybe the same question, but Maybe like Amirhesam, do you want to feel free to like add anything that you guys want if you have for any of the questions. I'm gonna try to like keep us moving, but and directed. But yeah, anything that you guys have that you wanna share?
Yeah, I guess if the question is like why we are doing CS today, I think uh,
Yeah.
it's kind of like life is kind of random because at least for bachelor, I guess in Iran, when you take the concours and you have like the certain ranks, then you have to do electrical engineering at Cherry for like then there is a list. If you cannot make it, you go to mechanical engineering. If you cannot, you go to computer engineering, and it changes. Like now, it's completely different. So back then, I did this. I take the concours and I had like certain rank and said, okay, I have to do this because it's the hardest. But that I regret it later because now if I go back, I do mathematics probably and computer engineering. And I was regretting like all the time when I started my PhD because I saw their like lack of like mathematical skills and coding. So the problem with the coding is in electrical engineering, you learn a lot of coding, but you're not as good as like computer engineering people. But on the other side, I really didn't like coding because I think dealing with this syntax is like the pain in the neck. It's just like you need to sit there and just make sure you're the right amount of semicolons and all those things. And even if you know the algorithm and you can solve the problem, you have to first like implement it. And I didn't like that. So, but that was like one of my regrets. I wish I could learn that better in my bachelor. But now this, thanks to Codex and Cloud, I'm very happy because that problem doesn't exist anymore. You can just use those tools to do it for you. And now you can think about like more high level things. But I guess one thing that really motivated me, it was this, again, I mentioned it like that we have a mathematical tool can distinguish between dog and cat. I guess this is significant because once you can do that, you can just build up and now do like language. So it was like obvious this is the future. But what I didn't realize is that it's gonna like grow so fast now that it's actually outgrowing like all the researchers and most of the engineers. So I don't know if it was like a right decision or not. Someone in the chat said I'm considering to go to the medical school. Maybe you should actually. Maybe AI is done. But yeah.
Yeah, it's definitely like it's good, cool to like hear like the stories of like why we came into it, but I feel like it's changing a lot now. There's a lot of people that are just coming into it because of the hype, and it's really important to like really understand if you enjoy the work that we're doing. So hopefully by the time this is done, like we can like you have a little bit of more like more like experience or like understanding of what the domain looks like today. Anything to add, Arya?
Um, I guess yeah, I would say a couple things that come to mind is like yeah, kind of like how what Hooman said. I don't know like I guess is there a way to like pull the crowd? Like I guess what portion of people don't know how to code and are like looking to know how to code if you like put up a reaction just so I can like gauge like what percentage of you are just like here to hang out with other CS people. I guess let's do like no code people right now.
So what should they do? They just raise hand
Just
if you
like
don't.
yeah, click like react and do something. Like like react and then I clap. That's mine. Okay, so we got like three people. Um, okay, so I guess I'll curate it for those guys first, maybe. And then there's a bunch of doctors here too, I guess. I'm just kidding. Um, yeah, I guess like the one thing is like, um, yeah, the like barrier to entry is like very much lowered now, but in the same way that like 10 years ago, all of like intro classes were open source, like all of Berkeley's, even like upper division classes were all open source, like you can just go take them. But like the main difference is like you didn't have a discussion TA or someone that if you didn't really understand something to like go talk to them. And so like that was always like I think for a lot of people like very demotivating because they like didn't understand a concept and it was a lot of times the TAs were too busy to like handle non-Berkeley people. Um, so, but like now, like with GPT, you can just like ask GPT and with a lot of like the CS concepts, especially like it's very, very good. So like if you are interested just like in the art of CS and like in the same way that like you're interested in like the art of semiconductors like 10 years ago, like it's like kind of like the same level of abstraction now. Like you can, it's just much easier to do the same thing you could 10 years ago, but you have your own like personal TA that you could go through that. So that's like the first step if you are interested. And then I don't know. I personally am not a subscriber to like the doomer scenario where there will be like an eternal lower class. Like I think there will always be hard problems. So like if you're interested, I would not. If you're here and like you are like years into your CS degree, like if you like think about the incentives of like the main CEOs, and if you like go talk to like the people who work at the labs, like all of them know like there's still a lot of hard shit to like figure out. But for these people like they need to like continuously like to fundraise, you always are constantly overselling. So that's what a lot of these people do, but it's also moving super fast. So it's like super important to like stay up to date. But like I don't see a scenario where like all of the software engineers will be unemployed in like 2 years. And also if they are employed, then all the people who like weren't software engineers now have to compete with the like really smart software engineers. So you'll probably be fine anyways too in all the other jobs. But yeah, it's my two takes.
Yeah, no, those are great takes actually. And it actually brings me to like, because I feel like the domain that we're in, there's a lot of things that you can actually do while you're in school. Like right now, the barrier of like learning things is definitely like lowered, right? Like you can learn with ChatGPT like any day, right? Like as your personal tutor. But I feel like at least myself, when I got into Berkeley, I had a sense of like I want to do everything. Like I want to get a research position. I want to try an internship. I want to get my hands dirty with AI models. Like I want to build stuff. And I feel like there's a lot in school, and also like even for people who are trying to get a job or like trying to like figure out what they want to do. So maybe we can transition a little bit about into what was the college experience like? Like what was undergrad or like what was school in Berkeley? What was school in Sharif or like looked like in that sense of like, okay, like what did you have to get done to like learn things, right? Like what did you have to do? Like did you have to do an internship, like do a research, like do hackathons, like do projects, and also like for I guess Amirhesam that went into like the grad school, like why did you think that you should go into grad school? Maybe we can talk a little bit about those as well. So yeah, anyone feel free to take that, like take a take on those questions.
Can go first. So for me, since I went to UC Davis for 4 years, I had a little bit of room to kind of experiment with different sort of approaches. Initially, also like, since I transitioned to the CS major, I kind of wanted to see what it offers. So I realized that a lot of folks go to internships over the summertime. And the way I optimized for internship was that I said, okay, I'm going to go to a different company for any internship that I go to. And also I try to go to a different tech hub so that I can explore a different city, as well as like learning about that tech hub and also like learning about the company and that sector. So initially, I interned at Splunk in San Francisco. That was my first internship offer. And it was honestly like one of the most memorable internship experiences I had. We had a really great like internship class. We had PM interns, finance interns, marketing interns, as well as a lot of software engineering interns. And the company also had a really good culture in terms of like they had happy hours, like free snacks here and there, like parties sometimes, even like on a boat party in Sausalito at the end of it for the intern celebration. And overall, it was a great experience. And I think like internships are a great way to like learn about the company culture. Like again, to this day, out of all the companies that I worked, no one beats Splunk culture in that sense. And then also the other thing that was valuable is that you get a sense of like who you're gonna work with. A lot of time internships at the end, if you perform well on your projects, you get a full-time offer to go back. So you already have a sense who your manager is going to be, who is the skip level. And these things are very, very important in a corporate and companies like structure. And then for my second internship, I went to Amazon in Seattle. In terms of the city, I think I chose the right place for the summer. Seattle in summertime is amazing, as a lot of people might know. It's like a heaven. People go like kayak on the lakes and everything, and it's really like sunny and it's really nice. But honestly, like Amazon was a great like sort of thanks stamp for my resume, and it opened a lot of door for me. But I didn't like the Amazon culture, given that, you know, it's very sort of tough and corporate and like focused on the business a lot. So it made me to like do another internship before graduation just so I can decide. And I was initially planning to go to a place that I can like potentially go back full time as my sort of initial strategy. And then I did another one in New York for Moody's Analytics. It's a credit rating company in the financial sector, backed by Warren Buffett. And I loved it. I worked on ML modeling and did a lot of data science work. And also New York was super, super fun. I never got a chance to live in New York after that, so I'm really grateful for that experience. But at the same time, I wanted to like stay in the Silicon Valley culture rather than like in New York or like finance culture. So I decided to like post-graduation look for sort of what are some interesting companies that are building cool stuff. I mean, that's the reason I got into it in the first place. And I found this very niche use case of augmented reality, which was really interesting. And because I also did research during my like regular semester and quarters, I was mostly interested in computer vision. And I think like whether you want to do grad school or not, even though I did grad school after that, doing research in undergrad, especially at a research institution, is extremely valuable. I worked on NLP, I worked on cloud computing and GPU computation, and also did a little bit of computer vision. And all of them give me a little bit of a taste what it's going to look like if I work on these problems. And I chose vision and joined Magic Leap as that augmented reality startup. So yeah, that's a little bit about those experiences. I highly, highly recommend getting all those experiences during your college time as a CS major.
No, internships are definitely a top like thing that people should be doing. And I know they're getting harder to get, and they're getting harder to do, especially if you're trying to get into like a big lab, because like those like AI labs, they don't tend to do internships. So but yeah, like try your best to just get as much experience as you can like through internships. Yeah, that's a good point. Thanks for sharing that.
I can
Amir,
go.
oh,
Oh,
Arya, go ahead.
no, I
Yeah,
have some
Yeah,
go.
go ahead.
go Arya, go Arya.
No, you go. No,
No, no, you
I
go.
want
Now
you
you
to go.
now you started. You have to finish.
No, it was an awkward silence, so I thought I'd just fill it.
Okay, sure.
Go.
I guess I have less like industry kind of exposure. My background, like all of my life, I was in academia. I have like a little bit of like exposure to an industry, but I can talk a little bit about like the bachelor, master's, and PhD because I did all, so I can have like some opinion about it. So I guess in the bachelor, so what's the point of like doing a bachelor? It's basically there are like so many courses. You get like a little bit of everything. They tell you, they give you like a very limited number of tools, and who is the best bachelor student is the one who used these tools very well, like in the final exam or in the projects. And then you stand out. You get like a good grade. Things has changed. I know like people now they're in the bachelor and they have like 7 NURBS paper, but back then it was not like this. So as long as you could just use tools right, then you get like good grades and you have a good chance to go like a good master program or a PhD program even. So then it comes to the master. In the master, things like get a little bit more like in depth. So the whole idea is the same as a bachelor, but now the course are more like project oriented. Now you have to do these projects and show I can actually do something, and you can talk about that when you're like doing interview with other companies, and you can do like do a little bit of your own project and have like GitHubs and stuff to show off your skills, like your coding. But at this point, actually, I'm very curious to hear about Hiva. He's still doing master. That all of these are kind of irrelevant because you can just ask ChatGPT to do like your homework for you, and you cannot really stand out if you do your homeworks good. And because you can like personalize, you have like personalized AI, you can just learn the course like much easier. Back then, it was just like random books and lectures notes like were all over the place, and then you have like to you had like a terrible like experience to learn the materials and also do a good job in the final exam. But right now it's just so easy. The homeworks you can just ask ChatGPT, you can just solve them. The project you can get help with ChatGPT and etc. But then the PhD actually is completely different world because like up to PhD you were just given some tools and the good students were the ones who can use them very fast. They could use them very flexibly and yeah, and they know like the tools were still limited. But in PhD, so still like the experience of the PhD is not the same for different people. Like if you just randomly choose two random PhD students, they will be having very, very different experience. They will tell you very, very different stories. But what like a scientific, like a theory, at least PhD looks like, is that now you are the one who comes up with the problem. You're saying, okay, I look at this field, I think like this thing is being done like not optimally, and you come up with a new way, and you say why this your new way is better, and you support it with like either theory or like a lot of experiments, and you try to motivate people to use your algorithm or whatever solution you have. Or it's like you like find like a phenomena. You say, okay, I don't know, Adam works or something like this, and like momentum works. Momentum can help like the optimization, something like that. And then you try to then say, okay, why this phenomena holds, and you came up with like some explanation, and you back it with like experimental result. And it is your job to define the problem and motivate it why this problem is important, and then solve the problem or just help people to understand that phenomena. So very, very different skill sets. And when you start your PhD, you just go to these talks and like the different talks, and you see like people from many, many different fields. They're all in the CS department, but many, many, very different things. And you don't understand anything because those people are just spending like their whole life on that specific topic. And then you need to learn this skill that if you go to a talk or you start like read a paper, how you can just find like the key things. Obviously, you cannot really understand the technical stuff, but how you can actually think in the high level way, which is completely in the opposite of like what in the bachelor or in the master. Because in the master, you have to solve the problem and give like the best final answer, and whoever gets it right is the winner. But here the story completely changed. You have to have the ability to see the importance of like these new methods or like the phenomena people talking about. And most of the time, many of them are actually not correct. So you have to learn what are the useful theories, what are the useful algorithms, and what are the ones that are actually limited, they're not universal, and they just hold in very, very specific settings. So I guess this is like the kind of the difference. And also in the industry, I guess I don't have like much experience as like Hooman has, but when I did like an internship in like Figma, they were like the AI company. They're not the AI company. They want to incorporate AI in their product. I feel like it's a completely different kind of environment. They just want to have a product to show off their product to their investor and say, see like what cool things we have, but they don't really think about the problem in depth. They just want like have a very fast solution work for a problem. But I can like talk more about it later.
Yeah, no, that's super helpful. Yeah, like the whole like master's, PhD, like I'm experiencing the same thing like in my master's. Like I feel like it's more of like it's like in between, I think, like undergrad and PhD, where like you can just use your master's to just do exactly what you did in your undergrad and just make more connections or do more projects. Or you can actually like use it to like gain more like those experience, like those research experiences that Amirhesam was talking about, like getting a research position and like doing a research project with a professor and like really diving deep into like a problem that you're interested in. Because for me specifically, after I finished my undergrad, I did take a year of continuing to do research and like trying to figure out if I want to do that PhD life. But like coming up, like looking at a work that someone else has done and like trying to come up with a now like a hypothesis or like a question to now try to find an answer for. That whole process is really hard to navigate and do, and it really requires like a good mentorship or like a good like resilience that I didn't think I had like after undergrad, that kind of like going into the master's, I feel like now I can like dive deeper into that. But still, like I think PhD just gives you that like sense of like being able to solve those problems. And like Kian said, like they're getting those offers because they know how to solve those problems, like come up with a question, come up with a problem, and like really look into like trying to solve those. Um, but yeah, I mean, I'm curious what your experience has been, Arya, because you didn't go into like the grad school. Um, you went into like job and then like starting your own business. So how was did you plan your undergrad that way? Like, was there anything you did specifically there or that
Yeah.
led you to that path or?
Yeah. I mean, so that decision was kind of made for me. I applied to a bunch of PhDs and they said no. So that, um, but yeah, I guess pretty much like, I guess I can describe like kind of my path and then the kind of takes I have. Um, but then, yeah, like I guess I'm trying to, yeah, PC first reference. Um, I have done that. It's not that hard. You just have to figure out how to yap. Um, but yeah, I can talk about that later if you want. Or also like feel free to like shoot me a what's it called? LinkedIn DM, or I can send my number or something. But yeah, pretty much, yeah, I guess what we like I guess my journey was like I did like high school robotics. So I was generally interested in like engineering and kind of thought that was cool, but I didn't necessarily like know what like what I was like really interested in. And then I didn't really fully like understand like what, and then my dad has like a PhD, but it's like a PhD in like he's like a civil engineer. So it's like very different. It's like he did it at Davis though. So like it's very different. And like I was like, yeah. And like most of my like people I was like inspired by were kind of like dropped out by the time I started thinking about doing a PhD. So I was like, okay, maybe do I need to do this or not? But then like I don't know, you have the Google people and Elon got into a PhD, but then they dropped out at the PhD. So actually like in undergrad, actually like my life plan, I told my uncle this multiple times, was like I'm gonna get into a PhD and then drop out to go make a startup. And then I remember it was really funny after I didn't get into the PhD, like my uncle said, he's like, okay, you can't make a startup now because you can only make it, you have to be able to, you have to drop out from something to make a startup and you don't have anything to drop out of. I was like, what do you mean? I can just like quit my job. But yeah, that was a funny joke. So I guess my plan was to do that. Um, I knew like I really liked robotics. And so I was really interested in just like continuing that in whatever capacity I could. And the electric race car team was like the best way to do that. And I don't know if this was necessarily a mistake, but more of like a problem of like knowing how to play the game, which I know I feel like in hindsight have a much better vision of how to do so. Um, and I guess yeah, like my so yeah, I did the like race car thing and I was like super passionate, would spend like 40 hours a week while doing classes and was doing that. And then junior year I realized like, oh, you can do a lot of really interesting stuff in research and it's very green field as well. That like it's harder to it's harder to get people to pay you to do that than to go to do a PhD in a lot of cases. And especially in undergrad, you can get these opportunities a lot easier because you have very high upside versus like once you're out of undergrad, you're just a person who has a job and it's a little weird to like go reach out to people and say I want to do research for you unless you say like I'll do it completely for free and I'll do it in full independence. And a lot of people do that. And if you're able to kind of lock in, that's a very good path too. But yeah, so I realized like okay, you can do a lot of really cool research, but I didn't really figure out how yeah, exactly. Just being kind of young and like being curious is like super helpful. But I think like I guess directing your curiosity into um like not explicit like results, but like tangible results is like really important, even if the results are like failure. So like junior year, I just met this guy in my Persian class who was doing ear EEG signal. He was building an ear EEG, and then he was like, "Yeah, I'm having this problem with like ML or like to classify the signals, and the ML people in the EE lab are really dumb." And I was like, "Oh, I just took an ML class. Like, can I just have the data and then like go and try to do it for you. And then like as I did this, I also like just wanted to be like a cool software engineer at like a FANG company because I thought um that I think in a lot of cases, sorry, I'm going all over the place, but like yeah, I guess my path was I did the race car club at that same time, was kind of continuing down like a non-PhD path of thinking like, okay, I'll just go work at a FANG company or a startup because I was really interested in startups. I had a sour taste. I like worked at a startup my sophomore year, so I was like, let me go try a larger company, see how I like that. So I did Amazon my junior year. Um, and then I guess another thing I wish I did was maybe continue after I got the Amazon offer. I kind of got really excited and stopped recruiting and just like went back to drinking. But I should have like continued after that to like look for other places because they had more defined internships as opposed to a general SWE, and you could define what team you wanted to be on, which was really good. Um, and then during that summer, I worked way less on my like internship code than I did like on the research code because I knew I was already like 2 years behind. I hadn't published a paper. Um, and so I would bring both laptops to work. I was interning remote in New York, but like at the Amazon office, I'd have my like stuff, and then I really like didn't do much Amazon work for the first 3 weeks of my internship. And my mentor was like, "What the hell, man?" And then I like locked in after that. Um, and then so I was kind of battling these two things, and I think it was great because I guess the next chapter of my life doing this startup, I kind of combined everything. But for the purposes of getting that PhD, like I think honestly, in some senses, I wish I did the PhD. Other cases, I'm like really happy I didn't. But if you want to, I think like being super targeted in the beginning and just if not papers, like creating blog posts, like create your own website. Like now it takes like it took me like I remember like a week to do when it was like maybe not a week, like a couple of days to do like when I had no AI, but like now you can do it in like an hour. Create the website. I think for and then knowing to play the game for PhD, like I did a bunch of really cool stuff for my in the electric race car club. Like it was all high ownership. There was no mentors. It was just like a bunch of kids in like a garage, and we built this race car that went 100 miles an hour and was like 600 volts, and it like was kind of a bomb on wheels. But like we did it all on our own, and then but at the end of the day, like that's kind of like not necessarily it's evidence that you're a great problem solver, but not necessarily evidence for like an ML PhD. So like I probably should have targeted that time a lot more towards getting my name on a paper, doing some blog posts, and going through and like just focusing on that, like playing that game. But for working at Fang, putting that on my website was super, super helpful because it showed high ownership, engineering, and stuff like that. But I guess, yeah. So what I'm trying to say is like play that worked really well for the one game, but it didn't necessarily play well for the other game of like getting into a PhD. And then so my plan was to essentially continue the research I was doing while working at Amazon, and I was doing that. And then the research kind of like fizzled out, I guess. The name or the research kind of fizzled out, and then I kind of decided like, okay, do I want to do a PhD or do I want to do a PhD because I'm interested in like the research, or do I want to do a PhD because I want to make a startup? And I guess the idea was like I can make a startup, and I kind of just like talked it through with my dad, and he was like, yeah, you could just make the startup. You don't necessarily need to get the PhD. So I just kind of started working on the sides. My downfall was essentially like my like I had a bunch of like co-founders issues, so I can talk about that like in private with other people. But like so these formative decisions are really important as well. But then yeah, in the end, like I was really grateful for all these opportunities because like in the end we were doing CAD and training our own custom ML models. We end up having to train on like 3 billion tokens. We're doing like really complicated mid training, had a state-of-the-art text to CAD model. Um, and it was like a combination of like my formula work, my research work, and then all the like hard software engineering, like the cool software engineering problems I was working on Amazon. And then yeah, we raised $5 million. We had like Arash Ferdowsi was like a seed investor. We met like Sam Altman like knows us now, but like yeah, we at the end of the day like that even after like that success, they all can go up in flames too. So like um yeah, I don't know what the question was, but that was kind of I think yeah.
Yeah, no, that's great. Yeah, I think there's a lot of like different paths once you finish your undergrad, and a lot of it can just come from the experiences that you get to have during your undergrad and your experience But a lot of it is also just kind of like sticking with your gut of like what is it that you actually want to do, right? Like in your case, you wanted to do that startup, so that's why you wanted to get in there. And like in Amirhesam's case, like he really wanted to work on those like hard problems, right? And like solving them. So it definitely like it's something that I think you pick up as you learn, as you do more experiences and do more projects. But I think it's, yeah, do reach out to any of us if you have any like um more questions about like those specific things. I think I do want to transition a little bit into kind of like what our, because we are running short on time a little bit, but what does your guys' day-to-day work look like in CS and AI? Like how does it work like using AI in software engineering, like in leading your team, working in research? How many of your technical skills that you learned, like you basically learned like during your school years, like you now apply? Because I love just joke of like in software engineering in CS, like in computer science, you never like the three things that you do are like very different. Like what you learn in school is very different than like what you study to get into a job versus what you do at a job are like so different stuff. Like what your classes look like is very different than like what you do for lead code to get into the job, and then what you actually work is like very different. So I think that's kind of something that it would be good to also talk about. Um, Maybe Human, I think you have a lot of work experience.
Sure.
What do you think?
Yeah, that's a great question. I mean, one thing about like our field is that things constantly change. So I guess the first principle you should have is like learn how to learn. I've heard that numerous times within my career in college. And like initially when I was graduating, I didn't take it as seriously. I was like, okay, I know how to code. I should be good. And then as you know, like nowadays, a lot of the coding is actually abstracted by these LLM and code generation tools. But I think the fundamentals still stay, even with lead code. Like, even though it's a different set of skill sets that you use for the interview to get past, you still want to showcase your understanding of the CS concepts behind it, whether it's a data structure or algorithm or a problem solving skill sets that you have. I think one thing that I actually really appreciate about our major is that, you know, a lot of the things that I learned at undergrad, in internship, research, even grad school courses still apply somewhere in my job, even though its shape and form might be different or its application might be different. So whether you learn about database somewhere in your system, you might need to capture some data. And it also depends on, your role specifically. But I think like the builder mentality is that the more you learn and you can absorb, obviously, the more competent you can become as a technical person. Day to day, I guess most recently at Meta, we had access to the latest models. We had access to all of them. And we host them like inside our private cloud infrastructure. So we can actually run our code base against them. So Meta is very well known for adapting tools and also being uh having that builder mentality. So like even we have our own internal calendar. We don't rely on external calendar services. And it's actually a great calendar service. Like you can chat to it and you can say, book me the next meeting with my manager next week at the time that is not focused. And it can understand it and parse your calendar and book it right when you are free. And I mean, I'm just using that as an example from something simple all the way to like I have these agent orchestrator that's running, 100 to thousands of parallel agents running at production level, touching like millions of posts per second. So one thing that I really like working about fan companies is the scale. So, even if I sit at my own desk with my own project, with my own LLM and, burn all of my tokens, I cannot really capture all of that data in the manner that I have access to in Meta. Like one of the projects that I worked on is like how can we train a model based on all the family of apps data like Instagram, Facebook, WhatsApp, Threads data that is almost as big as the internet itself to some degree in terms of storage and input in real time. So how can we use that data for training? And I think the biggest part of software engineering, which I don't think it's going to get automated by AI anytime soon, is the level of abstraction and problem solving that you have to acquire. Just like how Amirhesam mentioned in PhD, you kind of come up with your own problems. In the industry, also, because things are very rapid and things change constantly, a big part of your job as you go up the ladder is to how not to just build solution because that's actually something easy, we would say. We just delegate the task to code it up, but rather what problems do we want to solve? So for example, for this project, my team came up with like this like edge in the research that we can use all this data that we have that is so messy and it's all over the place to train even a better model or reasoning model. So that's one example. In my other jobs, I mean, before GPT era, obviously you had to spend a lot of time coding, looking things up on Stack Overflow, Google, internal documentation, external documentation, talking to people, asking whether they run into similar problem. But nowadays, again, thanks to the AI, you can do the context gathering and RAG-based questioning much faster. But also the parts that are um, still important, again, experimenting with new solutions. So things we have always coming up with new papers, new approaches. So you want to like take that, run experiments, apply it at production level, and kind of scale it up. And again, I think the only part that is solved already is just the coding generation, which is, I would say, a subset of an engineer task. The engineer task is to understand the problem, understand the solution, why those solutions matter, make the trade-off. Sometimes for one solution, for one problem, there's 5 different solutions. Okay, which one do we take? Do we take the one that is cheaper? Do we take the one that is more accurate? Do we take the one that has lower latency? Do we take the one that customer is more happy? And as technical lead or engineers on your teams, you kind of make these trade-off decisions. And yeah, I think uh, that's a summary I would give about it.
No, that's a great experience because I've also seen like that change a lot, like going from like just pure software engineering coding, system design and like running like experiments and like really figuring out like what are we trying to optimize for and like which solution is actually the best because AI comes up with like the simplest and worst solutions sometimes. So yeah, thanks for sharing that. It's very useful. Arya, Amirhesam, how about you guys? Anything to add?
I think I can go first this time. I guess one thing I've like started doing a lot that changed, I probably should have done this a little more in college, but like trying to like be very intentional about like reading. In college I would kind of like read textbooks, but like I wouldn't read like I don't know. I think I just had like a lot less time to like read other things, but like even if you go look at the most recent, like if you look at, I remember I was like really confused, maybe like 2 years ago, or like a year ago. I was like really confused, like how the hell did they like come up with like the Transformers paper? Like it seems like a lot of disparate things just kind of combined. And then my co-founder at the time was like, well, if you go read the papers like at the time, they kind of just like combined like a bunch of other stuff that people had generally been working on. And I think that also kind of comes back to like PhD and like research, whether it's in like a startup or in a PhD or just on your own, like a lot of the times, like if you want to think of a new idea, it like a really good idea tends to be like combining some disparate set of ideas that may not be super related and then figuring out the kind of golden line that connects them all. So I think like and especially like reading is like a really way to like learn about a bunch of different topics really fast. And a lot of the people who I've learned who are like who I continue to think are like really smart post grad, like continue to do this and have a bunch of like interesting ways of like finding new stuff to read, whether like not necessarily just ML papers, but just like other concepts too. So I've been trying to do that very like intentionally for the last like 2, 3 years, and I think I've learned a lot of stuff that way, and found ways to combine stuff in terms of like yeah my day-to-day um, like engineering load. Yeah, it's just a lot easier to learn now. Like I that's why I like really wanted to bring up reading because like that's still very serial. Like AI doesn't necessarily make that a lot faster. At the end of the day, you can find these like a lot of times like it's not enough, at least in my opinion, to just like get a summary and then just compile. Like the learning process of being really hard and going really in depth is like while reading like some textbook or some AI paper is like really important. So I'm a big believer in that. But like I do think AI like helps like figure out like what is important to read for me or something like that. Or for example, like I tried to like never look at my email or like calendar at all anymore. Like everything that I always hated doing. Like I literally like I missed that we got into like YC because I didn't check my email and then the guy called me and then I was playing basketball and my phone was in my shoe. Um, and then like I didn't know for like or like I was like waiting for like days and like I got back home for like basketball and then I was like, oh shit. Um, and then so like all these like annoying things. Most AI is like pretty good. I don't have AI send my emails, but I have it draft every single email and I just click yes. The one I use is like this thing called Poke, and you can like negotiate it with for pricing. So I pay like $1 a month for it. Um, but then on top of that, like for all the engineering tools, it's like Cursor, Codex, Claude. There's kind of like a infinite battle of who's gonna win. I think the biggest thing is like don't pick one, just pick the one that's like learn how to adapt really fast. The tools are going to change. Um, and then on top of that, like just as much as like reading is important, I think like writing things down is just as important. Like I have like I used to use Obsidian, but now I use like this other app, Notion. But I essentially just like try to like I don't know, in like 10 years, if you can think about it, like if AIs can like reason through everything, if you just have like a written log of your life and all of your thoughts at the current time, then your AI can just do the things you would do anyways. So like in my Notion, I just have like personal, like I have like a whole section that's like personal blogs, whether it's like something random or like a thing I'm interested in. I'll just like deep dive that for a day and I'll write in my Notion. And then for my future AI, like it just will know things. So and also it's like good for your brain to like write things down too. Like Mark Andreessen has this like quote of like the person like always look for the person who's writing things down in the company. That's the person who's like running things because they're going to be able to like go and figure it out. Um, so I guess yeah, make AI do the things you don't want to do, but like continue to do hard stuff. I would guess, or I would say, reading and writing things down are super important.
No, that's great. That's a great advice. Yeah, I feel like we should make a list of all of our favorites, the ones that we use and the ones that have we created that we can potentially share and like put them somewhere and share with students. I think that would be helpful if they're interested. Amir, is anything to add here for research or
Uh,
for PhD students?
yeah, I guess one thing is for sure. I guess the technical barrier has completely been lifted. So what was the problem before AI? You were talking to someone, that guy had like a lot of knowledge. But if you weren't like in his level, you couldn't really understand what he's saying because he assumes some stuff that you don't know. And then that conversation goes nowhere. You learn nothing, even if he's like the most expert person in that field. But now with AI, even if you download the most recent AI paper in theory, that is like 80 pages of like pure math, then if you ask like AI to just, okay, explain this to me and just go step by step, keep asking the question, then you can understand like a very complicated papers like in 2 hours instead of like a PhD expert, a student needs to read that paper for a week. So I guess right now we are in a very, very interesting point of like life, but I think AI can be used explore like other kind of fields. I guess people are very interested in AI to make AI better, but maybe it's like the best time to actually, I don't know, maybe the next big thing is quantum. Maybe it's like the uh, I don't know, high energy in physics. I don't know. But now we have like a extremely powerful tool that can technically help us to learn and understand any field in this world, even the biology. You can just learn it like in a month or two. So maybe I guess my advice is just instead of like forcing yourself to like do AI stuff, maybe use AI to go and explore something that has not been explored. And why this is like important? Because if you think how AI came about, uh, and even think about like the most prestigious like conference in AI, which is NeurIPS, it comes from Jeffrey Hinton. That he actually talked about this in the Nobel ceremony. That he didn't have funding. People didn't want to spend money on like AI research, and NeurIPS was one of like the least prestigious conferences all over the world. If you had a paper in NeurIPS, nobody cared. But now things has changed. But maybe this change teaches a little lesson that maybe if like everyone is like pursuing something, maybe that's not the right road, or maybe not the right road. Maybe you shouldn't go that road. Maybe you can use these powerful things to go and explore something that is actually more meaningful to you. Yeah, and I think even for me, I can still do that because we have these powerful things and we have like a lot of experience, so we can just explore other areas.
I have one thing to note on that. Like in using AI, like I think AI is like essentially being able to use all these models should essentially, like, a lot of people are very hesitant to pay for them. Um, and I think this is like a big gap. I would say everyone should have at least like one subscription to one of them because you're never going to get access to like the top stuff unless you do so. And you're going to just be however many months behind the top of the line thing is. I remember like I was getting lunch with one of my old profs, and he was like saying like the student, like you can tell which students are paying for like Claude Code, like 20 bucks a month, especially in like the upper divs classes, because they can do a lot of stuff in parallel versus the ones who aren't. And at the end of the day, like the $20 a month one for most people is like should be fine. I would say like normally there's like a $50 a month one. I would go for that one, just buy like 10 less coffees a month. Um, and then like that's like a big piece of advice I would give. It's just like just it's like buying a like in 2000 you didn't need to buy a laptop to go to college. Now like if you don't have a laptop in college, like what are you doing? Or like it's you'll figure out a way to get a laptop, whether it's through the school or something like that. um the same way it's like you should have some sort of subscription so you can be like on the front lines and just get access to that intelligence. But yeah.
Yeah, actually, one thing to add, my advisor forced me to get the pro version for ChatGPT. Now I'm paying $100 per month,
Yeah.
but it's still
Yeah.
totally worth it. It's a good investment,
Yeah.
definitely a good investment.
And the prices are also changing really fast too.
Yeah,
Like I think I went
actually,
back to like Cursor recently because like their new model is like much cheaper, and it's like for coding it's like relatively the same. And I can get access through like Fable, like through just API credits, which is cheaper, but I don't know.
but it's actually scary because if they do this for a while and then say, okay, from now on it's gonna be 24K, we are all screwed because
Yeah.
you're like too in the deep, like too much in the mud.
Yeah. I think all of them are probably like you're gonna have like companies try to cursorify themselves and just train their own models and serve them very cheaply, and then you're gonna have some combination of like locally running models too. Like um I think like
Yeah,
most consumer
I
ChatGPT
hope
will be replaced
people.
by Apple Intelligence. I don't know. Sorry.
I hope like this tradition of like releasing open source model like DeepSeek or Quen like keeps going, because if
Yeah,
that's not there, we are in big trouble, I guess, like in future. But
I agree.
Sure. No, these are really super helpful. I hope that the students are also finding these useful. I mean, we're all like, as everyone has been saying, like I feel like the field is definitely moving really fast, and I think we're also figuring it out as we're going through it. But yeah, if there's anything that we're using, it's definitely good to share with you guys and for you guys to ask any questions that you have. I know there is also like we want to switch to Q&A, so I do want to like move to like ask like one last question, but feel free if you want to ask your questions in the chat, feel free to put them there, or if like start thinking about your questions that you want to ask us. But as like a last, I guess, question, I kind of want to ask about like kind of like any advice or any like thing that you are going to think that AI is going to do in the next couple of year, like for the year or two that like students should be aware of. I know we talked about like yes, like there's this hype of like AI will replace people, but I feel like there's like also like the concept of there's going to be more problems, there's going to be more things, but how can you like stay on top of that? And um any of the like any advice that you have or like any visions for AI that you have would be good to share as like a ending
Yeah, I'll go first
before
with
I go to
this one.
questions.
I think like Jensen Huang, CEO of NVIDIA, has said this, so I'm gonna refer to one of his quotes. So AI at the moment is not really replacing humans, it's replacing human tasks. And it's not even saying human jobs, it's specifically saying tasks. So again, even in the context of software engineering and coding, which is the most prominent use case of Claude and its profit, it is focusing on coding generation. Even for debugging or like some of the testing or evals, we still have a lot of problems. And the nature of these large language model is that there are non-deterministic. So they're always going to have that hallucination aspect. There's always going to be some probability of error. And that's how humans are. We have a layer of imperfection. And that's actually going to be both a feature and a bug in this case. A bug in a sense that, yes, AI is not going to 100% going to replace everything. But there are areas, there are tasks that you can define, okay, I want this input, I want this output. I don't care what happens in the middle. And in that case, obviously, like those tasks and a lot of them are actually being automated at a crazy scale. So traditionally in tech, we always relied on sort of these scaling law, and then it would always be around hardware. So we would think that Intel, Apple, all these companies that make chips, every year they sort of double their capacity. So we will have a stronger processors, a stronger GPUs, all of that. Now the scaling law is changing. So you have these stack of components that are, sort of growing at a more exponential rate. So what do we do? Obviously we cannot stop AI from expanding. Even governments are trying it to some degree, but as of now, America and China are going to lead both ways. So a lot of like open source model coming out of their ecosystem in China, and also a lot of like closed source proprietary models from the US and Silicon Valley specifically. So I think for students, the best advice I can give you is still keep learning, and keep learning, as Amirhesam and also folks said, keep learning the most challenging problems that you can acquire and you find interesting. The same principles still stand. When the internet was booming during the 2000, even though I was not here in the US and I was like a kid, but based on the history lessons and looking at all the trends, a lot of it is actually very similar. So there was a boom of just creating fiber networks. So like Cisco and all these other companies were building like all the components to make the internet work. They kind of wired all over oceans, starting at that point, to create internet accessible everywhere. And yes, there was a crash. Yes, there was a bubble burst, but the applications that came after that were actually the big value of internet. So like companies like imagine Citadel. So one of the advantages that Citadel had at that point was they created a fiber network between Chicago, New York City. So they were able to like do the transaction at a like millisecond like ratio compared to their competitors in hedge funds, and each of those like millisecond transaction made them billions of dollars, and that's why they have this advantage even today. Even today a lot of companies cannot just create fiber optics between two different states. It's a lot of like regulatory compliance, all these other issues. So and another analogy that I like, it's by a prominent VC called Chamath. He's saying that AI is kind of like a refrigerator. So LLM is like a refrigerator. You can make the best refrigerator. You can make it like sing song or whatever that it does right now, or show you your family pictures on the display now and detect what objects are in it. But the things that actually get stored in the refrigerator are the most valuable companies after that. So think of Coca-Cola. Like Coca-Cola just used the refrigerator to store its food item, but it's becoming the number one drink all around the globe. So again, yeah, if you are into in medicine, if you're into law, if you're into architecture, if you're into um, AI itself, just use AI to build and compound on top of it and try to like tackle the most challenging problems that you can. And with AI, it's actually fun. It's like it gives you a dopamine hit when you learn all these challenging topics using it. So that would be my advice.
Amazing, amazing. Arya, do you want to go next?
Um, yeah, I guess Hooman covered a lot of the things I probably would have said. I think like yeah, just kind of like I think first principles thinking is a good thing to focus on. And like regardless of AI, like or yeah, regardless of AI, just being able to break down problems is good. And if you can do that, you can kind of use that first principles thinking to kind of decide if your path or yeah, so establish that first and then maybe kind of just think of paths that you are genuinely passionate about, like with or without AI or like chasing money or stuff like that. Um, and then use the critical thinking to decide like, okay, will this get automated, right? Um, because there are going to be like some jobs that will be gone and there will be some jobs that are still there but super different. Like a guy who used to be um, like working in the Ford factory as a or a guy or girl person who's working in the Ford factory assembling cars is probably 10 times more efficient than they were like 50 years ago. But their job is also very different than it was like 50 years ago, right? So just like I don't know, do like a like I think what I found is like very, very calming, I think, because there's a lot of like hysteria, is just like if you do the like game theory or like game theory is like a complicated word. Like if you just try to like do the think through like if X happens, what will Y be? And maybe think through those scenarios. I think in a lot of the scenarios, most people's incentives align for like there not to be AI overlords and for people to still have value and they're still being good work. So I think it's super important to just focus on things you still are really passionate about. Whether it's CS or not. Like I wouldn't hop on the AI train because it's like cool right now because you're probably already too late. But if you hop on the AI train right now because you're like super interested, it'll probably like that interest will carry you to be on to the next thing, right? Um, like I wasn't particularly like interested in like cloud computing, but I thought like what Amazon was doing was really cool, and I thought CS was really cool, and that led me to become a really great software engineer, and then that kind of led me down to building a startup and doing kind of okay. Um, so yeah, that would be my main advice is like just don't freak out and then think about things in like the context of decades, not necessarily years. I think that's like a really good advice. That's a really good set of like we had like a meeting with like Sam Altman and he was like good startups think that way. Because if you think of like, if I think of something in like the scope of a year, I'm just gonna like rush to like hire someone. But if I think of things in like the scope of like a decade, then like, okay, if I take an extra 2 months to like hire the best person as opposed to just hiring anyone, um, that person will stick around and probably have like yield a lot more value in the long term. So those are like the two things I would focus on. But yeah.
I mean, there's so anything to add.
Yeah,
Yeah.
sure. I try to be like brief. Actually, I think I'm not in the position to really give out advice. If my net worth went above like 100 million, I will come back and give advice. But I can just tell you how I feel. I feel like if like 8 years ago someone had come to me and told me there will be like a statistical Paris like these LLMs that can solve math and coding, I would say just get out of here. Like there's it's not possible. Math and coding is like the what makes a person smart. If you can do math and coding, you're smart. You have like a good future. But things has changed. And I guess I totally agree with Arya. I guess your passion is the most important thing. Um, when I look back, I feel like I didn't go to ML because it has like a good future and I could like make a lot of money if I have like a CS degree. I really enjoyed like to really understand how this model like separate between dogs and cats, and I'm happy with that, like alone, because this is very impressive how mathematically you just distinguish these two classes. And I think, yeah, the fact that AI is very cool, you don't really need to understand AI. You can just use it. So I guess it's really important. So for example, if you came up with like a way that you can make the inference time of these models 2 times faster, OpenAI will hire you and give you like $1 million probably to you. But do you really want to go to the details of this matrix multiplication and this implementation and really understand caching and all this stuff? Or no, you just want to think about, I don't know, maybe quantum. I understand like what like a wave looks like, right? Maybe that's more interesting to you. So now is like the perfect timing. So I guess the passion is a real thing. It might be very cliche, but I guess it's the most important thing, because even if you fail, when you look back, either way you can fail, but at least when you look back, you say, I did something that was cool and I enjoy it. So that's the difference, I guess.
No, these are amazing advice. I hope that everyone is taking them and using them. I think just one thing that I want to add is yes, like figure out your passion, and also once you do, go really all in, like build stuff and don't spend time doing things that AI can do. Spend time like going deeper into the things that you are interested in and like passionate about. Like you're doing a project, don't try to understand everything that is happening inside of the project, but go deep into the issues that you're facing and go deep into really digging into like what is going wrong. And then because it's in those cases that you really activate that critical thinking and you learn something. That's just my one advice. I think everyone covered everything else. I know we went so much over time, so I do want to make sure we're answering people's questions. I think Kian was very active in the chat, and I know he had to leave. So I'm sad that he had to leave. But I think Saina, you had a question about like getting any referrals and question. Feel free to reach out to any of us. We know people in a lot of the companies, and if there's something that we are doing that interests you, feel free to reach out to us and let us know. But yeah, I think the things that Keon mentioned of like reaching out to like people in the companies and like using your people that you know on LinkedIn, that definitely helps as well. Um,
Can I add something, Hiva, John,
yeah, of
for
course.
this? Yeah, I saw great question, Sino, by the way. This is definitely like some sort of a pain point for everyone, but specifically, like, I guess in our culture, like, there's some sort of a hesitation out of just the way you asked it, actually, like, out of respect, you don't want to like bother people or you don't want to like go out of your way to do it. But actually, like, think of referral as a two-way street. A lot of time, like, a person that refers you in a company, like let's say for a full-time job or a certain level or whatever, they also get like a referral bonus. So like, there's no like sort of huge favor or like one way sort of a benefit here. And even like putting that factor aside, I think one of the best ways that I found very effective in college was that, like for example, yourself, you went to Caltech, it's a great school, great network. So try to reach out to like your even alumni groups first. If you are doing a cold reach out on LinkedIn, a lot of time just mention, hey, like even if they probably see it on your LinkedIn anyways, but even if you're from any school, just reach out to the alumni in the industry, say, hey, like I'm looking for an internship. I'm class of like 20, like whatever, 2020, whatever it is. And then I'm looking for this. And once they see that you have a great resume, you have a, background experience, whatever it is, or your projects, most people are willing to help, especially like there's just like there's an openness in the culture of like tech industry. Like people are willing to help as long as you ask them the right way. So be a specific, share, like if you find a specific job role, that would make it even easier for them. So share the link to the job description and things like that. And I also like one thing that worked really well for me in college was going to career fair and like sort of talk to the person, whether it's a recruiter, whether it's an engineer, whether it's whoever that point of contact is. And I always tell this sort of in any scope. Think of like I have an ABC rule for it, audience before content. So make sure who you know whom you are talking to. So if it's HR, talk more about the company culture, talk about what sort of opportunities they offer or how often their internship program is. If it's an engineer, talk to them about like what exactly they're solving on their day-to-day job and try to relate with them at the technical level. And if it's obviously a hiring manager, you want to sell yourself, your portfolio, your skill set, and things like that. And don't be like, I guess when you are doing a first approach, whether it's for a referral or just directly asking them to hire you, try to be as impressive as possible. Sell yourself, show off your skill sets, and yeah. And if you find anything within my network, or I'm sure same goes with all the pals. If you find something in our network and connections, please reach out to us as well.
Amazing, amazing. Okay, also Amir Ali had two questions. Is do you also feel like you're losing the abilities and knowledge you had before, or do you feel that AI is fine because it acts as a kind of an abstraction built on top of your knowledge? And it says when it comes to academia, what do you think should change for university students now that they can learn so quickly with AI? Do you think the traditional academic model needs to change? I think we touched on it a little bit, but anything else to add? Oh, and also, if I'm really like you want to expand a little bit on your question specifically, feel free to do so. I personally see a big change in academia. Like a lot of the Stanford courses are changing. They're no longer like about like I think 50% of the grade for a lot of the courses are project based. Like it's the project that you do. The rest is like homeworks, and some of them have like a little bit of let me see. I mean, if we can learn everything with AI, what is the point of academia? Yeah,
Great
I think
question.
I had that question every day from myself as well. So
I mean, you
I
could
don't know if
learn
I'm gonna.
you could learn everything before AI too. Like
Right.
you could have become Einstein by just reading hella textbooks, but it's like,
Actually, that's not true, right? Because even if there is a textbook, there is a chance that you don't understand the textbook. But not now that barrier is also lifted because you can just give the textbook and say, okay, I didn't understand this. Can you explain?
but like
And
it's easier to do. But like in theory, you could still do, like okay, you could like in theory, like okay, let's like a much easier example would be like become a software engineer at Facebook. Like you
mm,
could 100% do that without a degree before. Um,
so they do, right? No, I don't know how it
no, that's
works.
what. But like but like this question, like it like ask yourself like why was that the case like 10 years ago, and like the same things like still apply right now, I guess, in my opinion.
I
Because
see.
like
Yeah, I also have a take here. So uh again, like looking at some of the like again, like there's a famous quote, history repeats itself, and it same goes with tech too. And the good thing about this field is that a lot of things are documented and you can make your own judgment looking at the data and sort of the reports that have been done. So for example, like there's a famous like practice in a lot of like programming. So you learn by uh, build a hello world project in Java, Python, whatever it is. So this was like a very classic example. So there's actually like uh, when the Star Wars movie was coming out, the first version, and also like few years after that, when the first computer program that actually wrote "Hello World" to the world, like I think it's back in 1970s or something, everyone at that point was figuring like freaking out. They were like thinking that everything is gonna get automated, like AI is here, sci-fi. Like they thought that Star Wars is happening in real time at that point. And then even in like 2000s, when the computer was coming out, There are reports, there are actually articles by New York Times, you can read them. They're saying that, oh, like basically a computer is gonna take over a human at a job force as the cost of the computer goes down. And if you look at it, to some degree, it's true. I mean, we have computers at our desk, but there's still a human element into it. There are parts that, again, AI is automating, but you have to also understand this is a huge take on Ian LeCun and why he's starting his own startup in the world model. The language itself, the language of human being, which is the essence of large language models and AI today, is actually bounded by language. So you have to think like, what are things that we do that are beyond language? So anything that is has to do with human emotion, almost impossible to replace with the current state of the art. You know, like anything that has a human component to it. That's why everyone says taste is really important, even for like AI builders that differentiate between your products. And then another thing that I would also say, yes, like you can learn everything, and you might think that there's no point in academia or degrees, but the point of the degree is not just to learn. So when you go to a university, yes, you want to get the degree, you want to pass your courses, and you want to learn the stuff about your major. But then again, it's important about the network that you create out of college. So I think even today, the institution with certain, alumni network, with certain brand names, with certain like geolocation are still extremely valuable. You know, like Stanford, just like Hiva John said, is more adaptive to changing its courses faster than almost any IB within the CS like departments, because it's at the heart of Silicon Valley, and it's, has investor and advisors and professors that are very well deep connected in the ecosystem. Whereas, other schools have different priorities and different locations. So you have to kind of figure out, okay, what kind of network do I want out of college, and what kind of experience you want out of academia too. Bachelor's, I think, just like we talked earlier, is a great time for you to fail in life, because up to the college point, you probably just pass your classes, you are cared with your parents and your loved ones. But once you get into college, you become like sort quote unquote adults. So it's a great time to experiment, to fail, to relearn. And now with AI, you have a new category to learn things with AI much faster and more efficient, and also more fun ways. All right, I'm gonna actually drop to if there's no other question. Because it's getting really cold in San
Yeah,
Francisco. I'm
let's
outside, yeah.
yeah, let's call it. Thank you everyone for coming, and thank you guys, the panelists, for like answering the questions, and also yeah, sharing your story. Yeah, feel free to reach out to any of us, fill out the pal connection request form. All of us are pals. And yeah, feel free to reach out to us on LinkedIn and our emails. Yeah, thank you guys. Have a great
All
night.
right.
Thank you.
Thank you.
Bye-bye.